material and information flow, then my current company background, and what all as a lean supply chain we have implemented at here at V Commercial Vehicles Bhopal. So, as already briefed by Yagnesh, I am a proud ADITian and currently working with V Commercial Vehicles Limited. So, it has been a journey of around 14 years till now, and it is going strong. So, I'll just skip the introduction and I'll move forward. So just to brief the team about the basics of supply chain management, like the term supply chain management, it was conceived long back in 1980s. It is conceived to express the need to integrate all the key business processes that are required for an organization to function clearly. And over the next 2 decades, organizations have mainly focused on the key terms that are involved in supply chain, like inventory management, customer demand, logistics of the parts, relations with the suppliers, benchmarking the new best practices with their competitors and all around the world, which are like these are the key areas which are integrated together to be termed as a supply chain management. So normally nowadays we focus and we talk more on the short forms like 3PLs and 4PLs on regular basis. So as you can see that from 1960s, the overall supply chain has evolved in broadly 5 stages. First is we started with warehousing and transportation, where the management focus was more on operations, performance, and efficiencies. So after that, in 1970s, 1980s, the total cost management came into the picture, and then the management focused shift on optimizing the operations curve and customer service. So this is where the shift came in. Uh, After that, in stage 3, as you can see, that integrated logistics management came into picture, and then strategies started to get evolving with respect to the logistics planning. So this is where the strategies and the analysis part started basically in the supply chain management. And as you can see that in stage 4, the real supply chain management, where the management focus started on co-evaluation, developing our suppliers together so that together both of us can achieve a common goal. So this is where the real supply chain management came into the picture. And now in this decade, in this century, like lean supply chain management is the key focus area with all the organizations who are targeting to increase their bottom line. So mainly the managements have started focusing on the online businesses, synchronization within the organization and outside the organization. And everybody is looking towards having a key factor, that is agility, because customer demand and supply changes very rapidly. And as we have also seen, like in past 2 years, because of COVID, there has been a drastic change with respect to the demand and the supply in each sectors. So here I will just be focusing more on the automotive sector. Going forward, this is just a pictorial representation of how the manufacturing industry is also in line with the supply chain, where in the back 1913s the assembly line concept started, and then mass productionization was started, which is pioneered by Henry Ford, as we all know. Then mass productionization need slowly arised. After that, in 1970, 1980s, the concept of MRP, materials, resource, and their planning, this came into the picture. And from 1990s, mainly Toyota, as we all know that Toyota way of working or Toyota production system, they started bringing in the new concept of just in time and TQM. So after that, ERP came into the picture from the 2000s, which is basically enterprise resource and overall planning, in which all the key business processes are linked together. And now going forward, looking at the sustainability part, the companies and the organizations are focusing more on long-term partnership with each other, development of a proper IT system which will enable them to have a monitoring on the overall efficiencies of the system. So this is just a brief on that. This is a typical supply chain flow. If in a layman's term, if I say that if we want to understand what exactly supply chain is, so this is just a typical flow where you can see that there are two things depicted. One is the material flow, where, as we all know, that steel and other raw materials are basically required to prepare a finished product that is required. So it basically starts with availability of all the raw material, contracts, discussion, sign off with the suppliers, and then basically BOM is bill of material checking with respect to what is exactly required by the OEM from the supplier. So based on that, the processes are started. Based on that, the facilities, machine availabilities, all the things are there at supplier end. And after completion of the process, the finished product is supplied to the main company, parent company, where it is used to assemble a bigger product, which will eventually go to the end customer. So here, as you can see that there are different stages where stocking, inventory, and logistics, movement of material, all this is involved at different stages during the overall cycle of supply chain. So the end result is finished product delivered to the customer based on demand. So as you can see, the material flow travels from left to right, and similarly the information goes back from customer to the main company, parent company, and the suppliers. So moving forward, now I'd like to just brief you regarding the background of my company, which is V Commercial Vehicles. This is basically a joint venture between Eicher and Volvo Group. In 2008, this is all started, where the strategic partnership was formed to drive modernization in the commercial vehicle industry. So as we all know that Volvo Group is a leader, a pioneer in technologies, developing new technologies, working on sustainability part. So this is where the key technologies came into the picture, and Eicher Motors, being a leader in the light and medium duty vehicle, commercial vehicle segment in India. This is basically from I can say from 4-ton gross vehicle weight to around 16-ton gross vehicle weight. So this is the segment where Eicher Motor is currently the leader, and Eicher Motors brings with it frugal engineering approach, and basically considerable infrastructure is also available in India with Eicher. So these two great companies came together, and V Commercial Vehicles was established with a vision to have new range of trucks completely driven across the light and medium duty segment in all over India, and of course out of India too. So this is where the synergy came into the picture. This is basically the vision that we started with to design the supply chain at VE Commercial Vehicles Bhopal. So as you can see that there were stringent timelines, and there were local ancillaries which were required to be set up. The area on which the focus was green packaging, where there should be recyclable bins, trolleys, pallets, so that less amount of scrap is generated. Standardization of the tracking solutions so that the overall turnaround time for the logistics operation, it is optimized. It should be well aligned, integrated with the IT part, where the backend working, backend information management is done rightly through the IT integration. So this is where the IT guys came into the picture. After that, you can see that there is a concept called as PHR, which is basically part handling and reviews. So whatever component is required in a particular truck, that component is manufactured at the supplier end, and it has to be properly transported to the main manufacturing plant. So this is where the PHR, part handling, packaging review comes into the picture. And finally, as we can say that going ahead with the lean concept, we need to drive JIT. JIT is basically just in time supply of the required bill of materials, parts, aggregates to the point of use. POU is basically the point of use. So once the finished product reaches at the point of view, then at that particular assembly line, it is directly used, consumed, assembled onto the required product. So basically what we have tried to achieve here is a very low inventory model. As you can see in point number 1, we have targeted inventory optimization. Going in the past, we can say that there are multiple stages where the component is handled. Just to make this concept a little bit clear, we also can understand our daily groceries and daily vegetable need, where it is produced at a farm level, and then it goes to a dealer, and then the dealer, from the dealer it goes to the distribution center, and from the distribution center again it goes to the vendor who sells this, and then finally it comes to our house. So this is what I have explained in the subsequent slides also. So maybe we'll discuss in detail in subsequent slides. So basically we have targeted here 2 hours of inventory instead of 3 days. So this is basically the past norms. Then normally we need to keep 3 days, 7 days inventory, so as to have a clear visibility on the production plan of manufacturing or assembling a particular vehicle. Basically, inventory is linked with the area, because as we go towards more inventory, you require 2 buildings, 10 buildings to store that particular type of inventory. So this is where the area comes into the picture. So it was targeted that with 2 hours of inventory will reduce the area requirement by 90%. So this is what we have done here at V Commercial Vehicles. Number of touch points, as we say in supply chain language, is basically handling of part from one point to second point. So reducing the number of hand exchanges for that particular part is also one of the important factor which can lead to increase in the quality level, because as we understand that if there is one specific thing which is handled 3 or 4 times or used 3 or 4 times, so during that phase there are chances of lot of damages. Also, handling multiple handling creates need for multiple manpower at different stages. So this basically drives up the cost of the overall product. So this is also one of the area where we have focused at V Commercial Bhopal. Also to avoid overproduction, like elimination of time based on the demand, we should be supplying the material and not just producing and keeping it that way. So this is also one of the target. Also, saving a lot of cost, as I explained on the area front, building less amount of area saves a lot of cost, and reducing the inventory to optimized level increases the operating profits, and there is a more number of working capital available with the company. So just moving forward, I'll be explaining this part in more detail. So as you can see that if we want to move towards lean, then we must eliminate these 7 wastes in our day-to-day processes, also in the overall manufacturing process, in the overall supply chain process. So over processing of anything should be avoided. Number of handlings causing defects which should be avoided. This movement of part from say 1 meter to 1 kilometer, that should also be optimized, minimized. Transportation, moving the material in a proper form, this is also a waste actually. So this is basically the area where the customer is not willing to pay to the company for this all things. The customer is only interested in the end product. So going forward, this all 7 wastes were taken into consideration on how to reduce this wastage in the overall design process. So just to brief you regarding some of the details of truck design, as you can see that there are overall 1651 parts which are basically required to be assembled, not actually manufactured. Number of parts getting manufactured are more, but if I see say at the assembly level, in the assembly line where basically the finished product comes into the picture, so overall 1651 parts are there approx, and the categorization is also mentioned. The more important thing is that the supplier base, as you can see, it is distributed nationally at different zones and as well as internationally, like import content is also there if I discuss for any vehicle manufacturing. So this is basically the mapping that first needs to be done for having a very lean supply chain system in place. So these are some critical aggregates which we call it. Aggregate is basically a combination of assembly of a lot of parts. So as we can say engine assembly. So engine is basically assembly of lot of things: alternator, motor, gear, pulley, piston, crankshafts, oil sump. So this is all there. Then we have a transmission assembly where there are a lot of gears, as we all know. Frame assembly is basically a ladder-based design which is used in commercial vehicle industry. And then we have painted cabins which are spot welded, and outer structure, outer envelope is prepared which is required to assemble a truck. After that, with respect to the powertrain, we require front and rear axle assemblies, which are basically required to deliver the final power output from the vehicle. And then to carry on the load, we have cargo body, uh, which is basically required to store any part required for transportation. So this is just an overview of the input that is required for overall planning of the supply chain. Going forward, as you can see, this is where the main Bhopal plant comes into the picture. So this is just to depict that material flows from a lot of area, basically. Like we have auto ancillaries. Ancillary is basically a tier 1 or tier 2 supplier that is situated just near about the main assembly line. This is strategically decided to ensure and to optimize the 7 wastes that we have discussed in the earlier slides. So basically to avoid to have less transportation time, to have less number of handlings, to ensure that whatever requires is not stored in over quantity, like overproduction is not done. Only the required quantity is supplied to the assembly line. So as I've explained, like major aggregates like frame, cargo body, front axle, rear axles, engine, transmission, cabin, axle. So this all aggregates, they are situated nearby area. And one thing very different that here as a strategy we have driven is having a different warehouse, not inside the plant. So this warehouse is basically just 500 meters or approx 1 kilometer far from this main assembly line, and it is operated in a 3PL 4PL concept. So 3PL 4PL is basically third party logistics or fourth party logistics that they handle and they store and manage. So we have tried to reduce the overall handling of parts and have a common location where we can store all the required parts, and as and when need basis, on just in time basis, these parts can be supplied to the main assembly line. So this is just an overview on that. This is a typical comparison that I was just trying to say in terms of number of handlings. Like if I say at our mother plant, which is at Pithampur, which is running from last 25 years. So there, the supply chain system is basically the suppliers send the material, it is stored to an 3PL warehouse, that is what we call it. And as you can see, we have 7 to 15 days of inventory stored here. This is basically on the count of supplier as well, which we called is at VMI, vendor managed inventory, and also on the count of VECV also. So this depends and varies on case to case basis. Then there are multiple docks at outside warehouse. We have other central store inside the plant. There we have around 3 to 7 days of inventory stored. So you can see that number of handlings being done for part is indicated here. And then based on the type of part, whether it is required to be assembled before supplying to the main assembly line, or it has to be supplied in a Kanban basis to the assembly line, or it has to be supplied in a kitting basis. So kitting is basically if I require 10 components and that 10 components are having 50 variants, then I'll be having specific that 10 components only for that particular model supplied on the assembly line. So here as you can see, there are around 6 handlings: C1, C2, C3, C4, C5, C6. Compared to that, if we say here, We have eliminated three handlings here. Directly the component is supplied. We have commonized the 3PL warehouse with our main warehouse, and all the sub-assemblies, kitting, all these things are done there only. So here we have eliminated three handlings, and after that the finished product as required at the assembly line. It is supplied directly to the assembly line in DOL, direct online, and just in sequence manner. So this saves a lot of time, lot of cost, and a lot of handling is saved in this concept. Going forward, just to brief you about the basic information flow or process flow, like there is a department called as Production Planning and Control Department. So basically, in the operational point of view, we have a lot of inputs that are required to ascertain a particular way of or a list of different type of products that should be manufactured in that particular assembly line. So it is basically all the stocks, availability of material, and then based on that input, we have this production plan preparation, different information flow to supplier on automated basis, and then based on that, basically considering all the supplier related parameters, final production sequence is prepared. This is basically called as production planning and scheduling and sequencing tool. So this is just an overview of that, because this is an input to the supply chain. Then as you can see, this is overall operational flow of how the communication or information will go for that particular system to work on. So as you can see, call off is basically a signal or an indication or a report generated from the main plant, which goes to the warehouse. Based on that, the warehouse picks different sub-assemblies, parts from its location. They are assembled, organized in the required form, and then again supplied to the main plant. So this is what we call it, basically a warehouse management process or a call off process inside the warehouse. Going forward, tracking the particular transportation or the movement of that particular part from supplier end or warehouse end to the point of use at the main assembly line is also very important, because if there is some gap in the transportation, some breakdown in the vehicle, or not timely dispatch of the particular required material, so there also like the IT part, the information flow is optimized and automated. As you can see that there are barcodes in part, and then we have finished good tracking at the supplier end, so that we are aware of their inventory as well, and that inventory basically is tracked through a unique ID which is managed with the truck ID. So as soon as the part for that particular truck reaches at our plant, that information we have already by just a scanning barcode. So this ensures that the information is also flowed in a speedy manner as against the physical movement of the part. So this is what is depicted here. Going forward, I'll just explain you the overall, like this is a typical layout of our manufacturing assembly line, where this central area is basically the assembly line. These are the nearby storage locations just next to the assembly line. So this is how we have executed to have just 2 hours of inventory that too in line with whatever model that needs to be manufactured. So, as briefed earlier, this is just a conceptual view of this actual area where the multiple trucks will be docked at multiple points, and as required at that particular station only, that part will be supplied. So this is where the reduction in the inventory, reduction in the overall supply cost, and as the material is just near to the assembly line, it is very much visible, and the information flows automatically. The main part here is there are no much material handling equipments like forklift or battery operated pallet trucks required, because the material is just supplied next to the assembly line. So this is a very unique concept in commercial vehicle industry that we have done, I think, first in India. So for this, I have just mentioned in my introduction also that recently only our company has won the Excellence in Supply Chain Management Award from the Machinist magazine. This is basically a magazine which is published by Times of India Group, and we have been recognized nationally also for this. So going forward with this overview, I'll just brief you about the automation level that is required for major aggregates, because these are the aggregate which have a lot of weight, which are bulky in nature, and which are very essential for a particular truck to get assembled on time. So as we have seen earlier also, painted cabin is one of such aggregate, and frame assembly is one of such aggregate. Front and rear axle, tire is also very complex, because we have different type of tires, different make of tires, and ensuring that all the tires of same make in a particular vehicle of same size, and in similar manner. So this is also one challenge which normally we face in the organization with respect to handling or supplying of these aggregates onto the assembly line. So here, as explained earlier, we have a near just-in-time concept. Wherever required, bare minimum 2 hours of inventory has been planned for these aggregates, and in a very automated manner. And wherever we can reduce, we have reduced the 2 hours inventory level also. As you can see that we have also implemented inventory on wheels concept. This is basically the inventory is there on the truck itself, and as required, it is used on the assembly line, and if not required, the truck can go back immediately. It can come here. So it is very lean in terms of operation. So just going forward in the details of this aggregates, this is a typical flow I've tried to indicate so that I'll be able to explain you all regarding the tire handling part. This is basically just in sequence supply. So as you can see, we have two dedicated docks. If I say for tire handling, this is the main assembly line where the tire is required to be assembled, so that a particular truck is rolled out. So these two trucks filled with the assembled tires come directly on this dock. The special feature part is that this truck also have conveyors installed inside the truck. So there is no manual handling of tires. The tires are automatically unloaded onto a conveyor system where they are stored in a sequence manner. There is a sophisticated program logic built into the system. So as required, tire is only picked and then it is supplied onto the left hand side and right hand side of the assembly line through overhead bridge, and this is then dropped down through equipment, and then it is used to fit onto this particular truck. So this is how, like, tire being a very bulky and important to assemble part, if there is some damage, cut, and being rubber, handling of tire is also very critical, because if we move it manually, because of weight, there are chances of it getting fallen down, or being rubber in nature, it bounces very hardly. So this is a very good automated system that we have implemented here at V Commercial Bhopal. So this is basically designed for building a truck every 5 minutes. So just going forward with other aggregates, engine being a very critical performance related part is required to be very systematically handled. So we have a separate engine assembly line where the engine and transmission both are coupled together, and then they are also supplied in a conveyorized truck. There is no manual intervention in between, and then these engines are unloaded onto a conveyor, and there is a overhead supply aluminum track based hoist system, which is used to supply from pickup point to the assembly line where the frame or the chassis is available. So you can see that normally with respect to the bulky parts, there is always a challenge of damage or multiple handling. So this all we have eliminated by introducing this automation at the required levels. Going forward, if I say for cabin handling, cabin being a very voluminous part and aesthetically important part, if there is some damage, then it is purely visible to the customer. So it is very important to not handle or damage the outer surface area of cabin, which is A class surface area. So there are unique conveyors and unique skids designed, implemented with a very special hanging arrangement for that particular cabin, so that not even a single component in the outer A class surface area of the cabin is damaged. So we have conveyorized based trucks, in that we have cabin which is received, unloaded, stored not more than 2 hours, and supplied in a very ergonomic fashion onto the assembly line. Going forward, front and rear axle, similar concept. We have conveyorized truck in which axles are supplied on vehicle set basis. Vehicle set is basically if one truck is having two axle, then the front axle and rear axle of that particular truck is supplied in one pallet. So this saves a lot of time and energy and effort to store a lot of inventory inside the plant, also ensuring that the required component is reached onto the assembly line in no time. So here also we have a conveyorized assembly truck which is used to supply axles, and then we have a very automated hoisting arrangement. So basically automation is done where we need to eliminate all the 7 wastes so that the system becomes very lean. Going forward, frame also being a very bulky component, we have, as briefed earlier, inventory on wheels concept, where we have frame stored on trucks itself. From truck only, we directly lift and supply onto the assembly line. So there is no physical storage. Once the truck is empty, the truck leaves, it goes to the supplier nearby to our plant, and there it is refilled with the required frames again, and that truck comes back and stands here. So this basically saves a lot of space in terms of storage, lot of inventory, because as and when production volume fluctuates, we can always increase the number of trucks. So this is basically very agile and very flexible in terms of uh, having lean supply chain. So here in all aggregate systems, IT also plays a very important role, where there are barcode implemented on each components, and then it is checked on each and every stages where the barcode is scanned and proper required material is there or not. This is also one thing that is ensured through integrating IT related solutions in the supply chain. Going forward, we have a parallel separate shop for cabin trimming. Cabin trimming is basically operation where the shell of the cabin, which is robotically welded, and then it is painted in the paint shop up to the required levels. This is basically fitted with all the interior related components, like you can see windshield, driver, co-driver seat. Then we have a instrument cluster where we call it as a dashboard, which has a odometer and headlamp leveling area, the gear knob, gear switch, brake pedal, ABC, accelerator, brake, clutch, fitment, and roof lining, door trimming. These are all the operations which are done into a cab trim assembly line. So basically, the concept is that a cabin is separately assembled, and then it is supplied onto the assembly line, where we have a chassis ladder type of a frame, and it is basically assembled onto that particular frame. So this is just a pictorial overview where we have implemented a very unique concept of not touching any aesthetic A-class related parts. So which is very important to ensure that there is no defect and the customer is happy with the delivered product. So moving forward, uh, what will be the future if we say in supply chain management? So this was just to brief regarding the lean supply chain and the overall part supply system that has been designed at the commercial vehicles Bhopal, because this is basically a futuristic part, and going forward, as we can see, there are a lot of uncertainties into the current market. Like technology point of view also, if we see, there will be autonomous driving cars, electric vehicles, everything, everything the world is trying to like connect with each other. Car talking with car, we have very live updates on our mobiles. Like if I give example of Amazon also, like if you order something on Amazon, then we have a very point to point update available with us, that your part or your purchase has reached from this location to this location, and people are like using future technologies on how to automate this supply chain. So the point here I'm trying to make is that there is a quite of uncertainty with respect to the demand and supply, or the customer expectations that will be there in the future. So there will be a different type of challenge. This is what I have tried to explain or try to depict in this slide, that going forward there will be manufacturing 4.0. The workforce will also be required to be transitioned to handle the upgraded technological involvements into the system. Overall, cars or commercial vehicles related demand will also actually fluctuate from uh, current petrol or diesel or CNG driven vehicles towards electric vehicles. So there will be different sort of components getting into the picture, like battery will come into the picture, where the government and the current organizations are striving quite hard to have a good supply chain system into place, from right battery manufacturing plant to the supply to the original equipment manufacturer. Because handling batteries, lead acid batteries is a different case, and handling this sophisticated technology enabled batteries will be a challenge. So similar product mix will be there into the future, and that is therefore very important for companies to basically have these four things integrated or adopted into their way of working or business processes. This is just apart from a study done by McKinsey, where you can see that for smart and intelligent supply chain 4.0, which we nowadays call it, moving forward, looking at the global uncertainties, as you must all be aware that currently people are after semiconductors. So basically there is a shortage of semiconductors all around the world, and in such scenarios, having a planning done for a systematic supply chain, it poses a very great risk and a challenge to address the uncertainties that are coming up into the market or into the scenario. So this is where we can leverage these new tools like artificial intelligence, machine learning in predicting, forecasting, scheduling processes. And we also can have predictive analysis of the customer demands. And then, as I have briefed earlier also, like robotic process automation, wherever we can increase the amount of automation level, so that reducing manual intervention will ultimately lead into a better quality product. These are basically required so that we have an increased real-time transparency across the supply chain network, improved insight into the customer demand, so that we can more and judiciously optimize the inventory and production cost, increasing manufacturing agility also, as the launch to go or the conceptualization to production or to the selling cycle of any product is becoming shorter nowadays. So we need to be ready to ensure that we are agile and we respond faster, in a faster speed to the market. So this is one part where it is required in future for the companies to adopt, so that they can leverage these all tools. And basically, in the last point, like AI and artificial intelligence and machine learning, which can have minimize the wrong processes that can happen into a supply chain or into a manufacturing assembly line. So I think this is the way forward. There will be a lot of new things that needs to be done, and lot of skill upgradation which will be required by the companies as well as the manpower. that will be using these technologies. So just a depiction on how these things will come into the picture, where we have everything data coming in and out of a very automated IT enabled system, where as you can see, going forward, drones will also be used for supply of parts, of components, autonomous trucks, so that there is no manual intervention, the time is fixed, and then uh, we can commit exactly, the OEMs or the equipment manufacturers, product manufacturers, they can commit very accurately to the customer with respect to the delivery time. So there is a lot of automation and data analysis that is required going forward in supply chain management. This is a overview of how we have value drivers in supply chain 4.0, as agility being the key in capital cost service areas. As you can see, planning is very important, physical flow, automation in physical flow, performance management, understanding what is right, what is going right, what is going wrong, and managing all these things. So basically, if we focus on these areas and enable our organization to be agile, then a company can be very well moving towards the supply 4.0 concept in the future. So thank you very much to all of you for listening me for such a long time. And I think the house is now open for question and answers. Thank you.
Participants having any questions related to lean manufacturing and supply chain management may ask to the speaker. It is now open for all. Yes, anyone?
I think I was quite relevant, or I was up to your all expectations, because this is the first time that I am doing this type of session, and maybe a open feedback for me could also be a great thing for me to start moving forward.
Uh, Here I have only one question that this tool can be implemented only, it is a concern with the size of component, or we can implement if we having the small size of component, having the very bulk in number. So can we implement the same tool for the other component?
Yes, Yagnesh, your caution is well taken. So basically, there is no one solution that fits all. So there is always a we need to customize that particular solution to meet each and every organization's need. Like for Eicher or we commercial vehicle, it is a large scale operation. So investing that amount of money, having that particular system in place is very well required. But your question is like similar system can be implemented, but then overall cost of product or overall operating cost or the bottom line of the company needs to be understood.
Okay, thank you, thank you.
Yeah.
So anyone having the questions? Otherwise, we proceed for conclude the session.
Hi Darshan, Mahesh here.
Hi, good afternoon, sir.
Hi Mahesh. Hi Darshan. My question is, can you just focus more on this uh, AI and GIT collaboration? How AI can be useful for GIT?
Sorry, AI can be useful
Useful
for
for JIT, just in time.
just in time. Okay.
Yeah.
So basically, sir, to answer your question, like moving forward, what I envisage is artificial intelligence basically can support us in understanding the predictions. Like if I say with Aisha, I have around 100 type of trucks available with me to sell to the market. So whatever customer needs are there. If I say if I'm selling a truck to Amazon, if I'm selling a truck to a vaccine manufacturer, so both will have a different specification, different requirements, and that in turn will have its linkage to the supply chain. So basically, the bill of material involved in assembling these two different type of trucks will change. So if we have artificial intelligence in place, then maybe we'll able to more accurately understand or predict the customer needs, and this in turn will help us in getting lean actually. So if we are getting lean, and for just in time to work, we need to have a very strong input. If the input is not strong, like if I am not accurately predicting or forecasting, then just in time can fail. So hope I am able to clarify.
Yeah, yeah.
Thanks.
So it's basically about forecasting the demands.
Yes, understanding more accurately the demand
The
supply
demands and supply.
scenario, and that varies across the regions also, and there are a lot of factors like.
Yes. Okay. Thank you, Darpan. Thank you.
Yeah, thanks guys.
Anyone having the question? Okay, so we likely to conclude this session. First of all, I would like to say that I'm happy to see you after a long time through this platform. Thank you very much, Mr. Darpan, for accepting our invitation as an expert lecturer for this faculty development program. And thank you for sharing the information knowledge, whatever going on in we commercial vehicle about the lean manufacturing and supply chain management. So it is a really nice presentation for the participants. Thank you very much.
Thank you, Agnesh. Thank you all for listening. Thanks.